Good morning to all of you, especially to Ma'am Eileen. This is Peter Andre C. Herbito, the former reporter of Group 2. And I warmly introduce to all of you my co-members. Without them, this reporting would not gonna be work. So let's have Mr. Hamza Mampao, Mr. Jandal Hussein, Mr. Wahid Kalimbaba, and me. Our objective is not to persuade you to take stand in this lesson, but we would like to try and share our knowledge with you to educate you. So, without further ado, let's get started. The concept of work. What is work? In our daily life, anything that makes us tired is known as work. For example, reading, writing, painting, walking, etc. Whatever you do, that is part of work. Work definition in physics. Work is said to be done when a force acts on the body and the point of application of the force is displaced in the direction of force. So when you put force to an object and it moves, and that means that is work. Work equals force into displacement, or W equal F multiplied to S, where W is work, F is a force, and S is displacement. So let's take a look in picture number 1. We see a girl pushing a wall, right? But no displacement, so no work is done in this scenario. So let's take a look at picture number 2. Force is applied in the ball and it moves, so that means there's a work here. So we have here direction of force, positive and negative work. If the body is displaced in the same direction of force, work done is positive. And if the displacement is against a force, the work done is negative. And if the displacement is perpendicular to the direction of the force, then work done is 0. So let's take an example here. When engine works to accelerate or move the vehicle, the work done is positive. But when brakes are applied to stop moving vehicle, then the work done is considered as negative. And that would be all. Peter Andre C. Herbito, the former reporter of Group 2, signing off. Thank you.
What is work? Work is defined as a force causing the movement or displacement of an object. So it means work is the energy transferred to or from an object via the application of force along the displacement. In the simplest form, it is often represented as the product of force and displacement. A force is said to do positive work if it is a component in the direction. So here, for example, when a ball is held above the ground and then dropped, the ball is fall is equal to the weight of the ball multiplied by the distance to the ground. So here's the question. Work is said to be done when applied net force on the object is parallel to its displacement. When Riza pushes a grocery cart, for example, an applied net force is exerted on the cart, causing the cart to be displaced in the direction of the net force. If she exerts a 500 N net force with a resulting displacement of 1 m, then W equal F and D. In short, force and displacement, and W equal 500 N and a quantity of 1 m, and W equal 500 G. So how they did get the 500 J? Here's how. Just remember the formula. W equal force times displacement, or W displacement times force, or D times F. So the force here is 500 N and the displacement here is 1 m. So you just multiply them. So 500 N times 1 m. So the answer is 500 J.
Good morning, Ma'am Eileen. I am Hamza Pimampao from Group 2. Joe. Joe is the standard unit of work named in honor of James Prescott Joule and his experiment on the nature of heat and its relationship to mechanical work. In more fundamental terms, 1 joule is equals to 1 Newton meter and term. In terms of International System Base Unit, 1 joule is equals to 1 kilogram times m squared or s squared. The joule is a derived unit of energy in the International System of Units. It is a equal of the energy transferred to an object when a force of 1 Newton acts on the object in the direction of the force motion through a distance of 1 meter. That's all.
Hi, my name is Abdullah Kalimbaba. I'm going to discuss fig about Reza pulling a traveling bag. May it be may it be along the vertical or horizon. We know that work can be done as long as the net applied force is parallel to the displacement of the object. But what if Reza pull a traveling bag? Is work also done in this case? In cases where the net force is not exactly parallel to the displacement, then component of the net force parallel to the displacement is used. Using our knowledge in right triangle adjacent, the adjacent side can be determined using the cosine function. Costhetic equals to adjacent over net force. Explanation. In the given figure, it shows that Reza is pulling a traveling bag as it was stated in the book. Work can be done as long as the net applied the force is parallel to the displacement of the object. In the case of that shown figure, the net force is not exactly parallel to the displacement. Here we will need to find the component of the net force that is parallel to the displacement. Based on the figure by using the cosine function, we will able to find the component of the net force that is parallel to displacement. Thank you.
And that would be all. Thank you.